For the first question, it says a window cleaner's ladder shown in figure 1 is narrower at the top than the bottom. It has a weight of 350 newtons and a length of 5 meters. When it lies flat on the ground, a force of 80 newtons needed to lift the narrow end off the ground. The first component asks, how far is the center of mass from the narrow end? And what can we do first is label the forces in the diagram. So it says on the narrow end a force of 80 newtons is required. And then it says that the weight of the ladder is 350 newtons, and the weight will be acting downwards at the center of mass. We can say it's somewhere over here. And then it's 350 newtons. And ask how far is the center of mass from the narrow end, so we can say this distance is equal to x, and what we can do is set the moments to be equal to each other, so basically equilibrium moments, and around this pivot. So the first component, what we can say is 80 newtons times 5, because the ladder is 5 meters long, and then equal to 350 times its distance from the pivot, and that will be 5 minus x. And then we can resolve for x. And this will be 27 over 7, and this will be approximately 3.86, something like that, meters. And then this will be the answer for the first component of the question. And for the second component, it asks, what force is required to lift the wide end of the ladder off the ground? What we can do is set up another equation that considers the equilibrium of moments. However, it's around this pivot, and then there will be some force acting upwards this way, and we can call that force F. So basically, F times the length of the ladder is equal to 350 newtons times the distance from the pivot, that will be 27 over 7. It's calculated from the previous question, and then therefore F will be 70 times 27 over 7. So therefore F will be equal to 270 newtons. And this will be answer to the second component of the question. And for this other question we're going to look at, it says, a ladder of length L and mass m with a uniform density rests against frictionless vertical wall at an angle of 60 degrees to the wall. What we can do first is draw a diagram. And the ladder says it's 60 degrees to the wall, so it will be something like this. And this angle is 60 degrees. And then it says the lower end rests on the flat surface with a coefficient of static friction mu s is equal to 0.4. A student with mass m is equal to 2m attempts to climb the ladder. What fraction of the distance of the ladder will the student have reached when the ladder begins to slip? Okay. Let's label the forces first. What we know is that the ladder of length L and mass m is with a uniform density. So we can say the center of mass of the ladder is basically at the center of the ladder. And it's the force acting downwards, basically the weight will be mg. And the student will be somewhere over, let's say over here. And then his force or her force acting downwards will be 2mg. And there will be no more reactions of the ladder to the wall. There will be a normal force. So let's say it will be N and R. This will be N, and we can call this R. So, and there will be also, we need to consider friction because it says, the question wants us to calculate when does the ladder slip, basic condition for it to slip. So we have to consider friction. The friction we have to consider will be this way, indicated as the blue arrow, and then the friction. So let's resolve the friction first. So basically, F will be equal to mu times N, and mu is given, which is 0.4, and the normal would be mg plus 2mg. So therefore, this will be 1.2 mg. And then, if we look at the diagram over here, we can see that R is the only force that is acting opposing to the friction. So what we can do is establish an equation that says R is equal to F, and then before that we can express R as some kind of function in terms of the distance that the student is up the ladder. So we can say this distance is x, and we will be able to resolve x. Okay, let's start with resolving for R. What we can do now is consider the moment around this pivot. So let's resolve the angles first. So over here, we know that this will be 60 degrees because this is parallel, and then this will be 60 degrees as well. And for R, this will be 30 degrees. And so therefore we can write down this equation. So basically, mg times the sine of 60 degrees times L over 2 plus 2mg times sine of 60 degrees times its distance up the ladder, which will be x, is equal to r times sine of 30 degrees and time its distance, which is basically L. Now we can simplify this equation. So we can factor LMG over this side, and sine of 60 degrees is square root of 3 over 2. So, and then what's left inside the brackets will be L over 2 plus 2x. And then over at the other side of the equation, sine of 30 degrees is equal to a half, so a half r times L. And then we can further simplify. We can divide the 1 over 2 and L over to the other side, so r will be equal to the 2 cancels out each other, so mg square root of 3 times L over 2 plus 2x over L. And not going to further simplify this yet. I'm going to establish the equilibrium first. So the ladder will slip when R is equal to F. So we can write down this equation. 1.2 mg is equal to mg square root of 3 times L over 2 plus 2x over L. And then we can cancel out the mg's and time L to the other side. So 1.2 L is equal to L over 2 plus 2x times the square root of 3. and then we further simplify. We can divide the square root of 3 over to the other side, and then what's left is 2x is equal to 1.2 over square root of 3 times L minus L over 2. Therefore, 2x is equal to, factor L out, 1.2 over square root of 3 minus 1 over 2 L, and then we divide 2 the other side. So and then it says like fraction of the distance of the ladder, so we can divide x by L, which will be the fractional distance, is equal to 1.2 over 2 times root of 3 minus 1 over 4, and we can resolve this now. So 1.2 over 2 times square root of 3 minus a quarter, which will be approximately 0.096, and this will be the answer to the second question.